more hydrogen atoms are replaced by halogen atoms. Okay, so here what is happening? So here one or more hydrogen atoms are replaced by halogen atoms. So these are called as haloalkanes. Okay, so haloalkanes, as they are replaced by halogen atoms, so they are called as haloalkanes. Yes, so we were discussing about haloalkanes. So as these haloalkanes are called as the halogen derivatives of alkanes. Okay, so what is the general formula? It is CnH2n plus 1x. So these are called as the aliphatic hydrocarbon. These are called as the derivatives of aliphatic hydrocarbons, where one or more hydrogen atoms can be replaced by halogen atoms. For example, so if this is a aliphatic hydrocarbon, if I take a aliphatic hydrocarbon CH4, okay, that is a methane. So methane, so either one or more, so one or more hydrogens, if they are replaced by halogen atom. So suppose if I interchange one of the hydrogen by halogen, so it will be CH3X. So this results into a alkyl halide. Okay, so this is a alkyl halide, or they are called as the halogen derivatives of alkanes. So these are haloalkanes. So remember the general formula. It is CnH2n plus 1 into X. Okay, so this is the general formula. Then what are haloarenes? So these are haloarenes. These are aryl halides. Okay, haloarenes, these are aryl halides, and these are also the halogen derivatives, but these are the halogen derivatives of arenes. Okay, arenes means what? They have aromatic ring. Okay, so they have aromatic ring. So they have aromatic ring. Okay, so they have an aromatic ring. So halogen derivatives, they are the derivatives of arenes. So why they are the derivatives of arenes? Because they consist of aromatic ring, and their general formula is ARX. AR represents the aromatic ring. For example, okay, so this is an example of a halide. Okay, so this is a example of what do you say, haloarene. Okay, so in haloalkanes, so what is the major difference? In haloalkanes, you have a aliphatic hydrocarbons. Okay, wherein here the halogen atoms is attached to sp3 hybridized carbons. Here, yes, so this halogen is attached where it is attached to the carbon which is sp3 hybridized. Okay, in haloalkanes. In haloarenes, the halogen atom is attached to what? It is attached to sp2 hybridized carbon. Okay, it is attached to sp2. So here the halogen atom is attached to the carbon which is sp2 hybridized. So there will be a double bond, right? So you know, sp3 means what? The carbon will have single bond. Okay, so this is sp3 hybridized. So this sp3 hybridized because all the bonds to which it is bonded, it is single bond. Whenever you have a double bond, so the hybridization of this carbon will be sp2, and whenever you have a triple bond, the hybridization of the carbon will be sp. So this is the hybridization. So these are haloalkanes and haloarenes. Now next we'll see the nature of the CX bond. Okay, what is the nature of this alkyl halide bond? Okay, so when we are talking about the nature, here you can see that in alkyl halides, the CX bond. Okay, in alkyl halide, the CX bond is partially polarized. Okay, so in alkyl halide, the CX bond is partially polarized, so that because the halogen atom is more highly electronegative. So when you know about the electronegativity, when you compare the electronegativity between the carbon and the halogens, they have high electronegative. Okay, so they are highly electronegative than the carbon atom. So as a result, there will be partial negative charge on the halogen and partial positive charge on the carbon. Okay, because the halogen is highly electronegative than carbon. So because of this, there will be polarizability developed on this bond. So thus this CX bond will be a polar bond. Why? Because in alkyl halide, between the carbon and halogen, halide, that is halogen group which is attached, will be highly electronegative. So because of the inductive effect, so you have studied about inductive effect. So because of minus I effect, so what it will do, this halogen atom will tend to pull the electron towards itself. So as a result, there will be partial negative charge on halogen atom and partial positive charge on the carbon atom. Okay, so thus this is the nature of the CX bond. So you can see here. Okay, so carbon will develop a partial positive charge and halogen will develop a partial negative charge. Thus, this CX bond is a polar bond. Okay, so it is a polar bond. So this is the nature of the CX bond. So next we'll see the classification. So on the basis of number of halogen atoms, so based upon the number of halogen atoms, so they are classified as mono, di, or polyhalogen. So based upon the number of halogen atoms, if there is one halogen atom, okay, for the compound, then it is called as mono. If there are two, it is said to be di. If there are three, they are tri. Okay, if there are four halogen atoms, then they are called as tetra. So more than three are called as polyhalogen compounds. So whenever you have more than three halogen atoms, then such compounds are called as polyhalogen compounds. So depending upon the number of halogen atom, if it is one, it is mono, two di, three tri, 4 tetra, etc. So depending upon the number of halogen atom, they are given the number. Okay, so you can see here the first three examples are for alkanes. Okay, alkanes means aliphatic chains. Okay, so they will be having a straight chain compound. So here you can see there is one X. So it is a monohaloalkane. So there are two halogen atoms. So it is a dihaloalkane. So here you can see there are three halogen atoms. So it is a trihaloalkane. So these are the examples for haloalkanes. Then the second set of examples are the examples of haloarenes. Okay, so you can see there is one. In the first example, there is one halogen atom. So it is monohaloarene. In the second, there are two halogen atoms. So it is called as dihaloarene. In the third, there are three halogen atoms. It is called as what? Trihaloarenes. Okay, so this is the classification based on the number of carbon halogen atom. Okay, so based on the number of halogen atom, so this is the classification. Okay, so we'll go for the next classification. So next classification is based on the hybridization of carbon atom. So based on the hybridization of carbon atom, so the first class, it is classified as the compounds containing sp3 hybridized CX bond. So what do you mean by sp3, sp2 and sp? Just now I have explained. So the carbon, okay, so if they are bonded by single bonds, okay, now here this carbon, suppose this is a methane, okay. So if I take a methane carbon here, so what I can say, what is the hybridization of this particular carbon? It is sp3 hybridized because it is attached by a single bond. Suppose I take a alkene, okay, I take a alkene here. Now here, if I want to know the hybridization of this particular carbon, so this carbon is bonded by a double bond. Okay, so there is double bond. So this is sp2 hybridized. Now, when it is having a triple bond, so this is ethyne. Okay, so the hybridization of this carbon, it is sp hybridized. So whenever there is single bond, it is sp3. Whenever there is double bond, it is sp2. Whenever it is triple bond, it is sp hybridized carbon. So this is the hybridization. So the first we'll see depending upon the sp3 CX bond. Okay, the first is alkyl halides. So what do you mean by alkyl halides? So alkyl halides are such a compounds in which the halogen atom is bonded to a alkyl group. Okay, you know what is alkyl group? R represents your alkyl group. For example, methyl, ethyl, propyl, butyl, okay. So pentyl, hexyl, etc. So when you remove, so suppose methane, okay, if you remove one hydrogen from this, okay, remove one hydrogen from this, it results into a methyl group. So methane, okay, what you have to do, ANE is replaced by methyl, okay, YL. So this is the alkyl group. So suppose if I want ethane, CH3 CH, okay, CH3 CH3. So if I remove one hydrogen, so it will be CH3 CH2. So this is a ethyl group. So these are the alkyl groups. So based upon the number of carbon atoms which are attached, you can take the alkyl group. So whenever the halogen atom is bonded to an alkyl group, that is R. So the general formula, as I discussed, it is CnH2n plus 1 into X. Okay, so depending upon the classification, so it is further classified as primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. Okay, now what do you mean by primary alkyl halide, tertiary, secondary, and tertiary? Now, if the halogen atom is bonded to a carbon which is attached to only one alkyl group, okay, if it is attached to only one alkyl group, then it is called as primary. Okay, suppose the halogen atom is attached to the carbon which is further attached to two alkyl groups. Okay, two alkyl groups, then it is called as what? It is called as secondary carbon. Then the third one, halogen atom, if it is attached to a carbon which is further attached to three alkyl groups, then it is a tertiary carbon. So this is tertiary. The hybridization of this particular is tertiary. So this is primary, this is secondary, and this is tertiary. So depending upon, so the halogen atom is bonded to the alkyl group. So thus they are called as alkyl halides. So these are further classified based upon, okay, depending upon, so they are depending upon the number of carbon atoms to which the halide, nature of the carbon atom to which the halogen is attached to. So it is classified into primary, secondary, and tertiary. So this is the first classification. Then we'll go for the second one. Second one is allylic halides. Now, what do you mean by allylic halides? So allylic halides, in this compounds, the halogen atom is bonded to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. Suppose, okay, CH2 double bond CH. Okay, so what is happening here? So the halogen atom, what did I say? Halogen atom is bonded to a sp3 hybridized carbon. So what is the hybridization of this carbon? It is attached to single bond. So this is a sp3 hybridized carbon. So halogen is bonded to a sp3 hybridized carbon, which is next to a carbon with the double bond. Okay, which is next to a carbon atom to a carbon-carbon double bond. So thus they are called as what? They are called as allylic halides. Okay, or it is called as allylic. This carbon is called as allylic carbon. So what is happening in allylic halides? Halogen is attached to the carbon which is sp3 hybridized, which is next to a carbon-carbon double bond. Remember, very important. Okay, what are allylic halides? So this is an example for haloalkanes because this is a straight chain. So if I give you an example for haloarine, okay, so this is the example of haloarine. So again, same definition, halogen atom is bonded to the carbon, which is sp3 hybridized, which is next to a carbon, which is having double bond, right? The statement is clear for both the examples, right? So this is the way you are going to apply it. So what are allylic halides? Allylic halides are those in which the halogen atom is bonded to a sp3 hybridized carbon, which is next to a carbon containing double bond. Okay, so those they are called as allylic halides. Next is benzylic halides. What do you mean by benzylic halides? So benzylic halides, in this, the halogen atom is bonded to a sp3 hybridized carbon next to a aromatic ring. Okay, so I'll give you an example. So benzylic halides example is this. So what did I say? So here the halogen atom, okay, the halogen atom is bonded to a sp3 hybridized carbon. Is it a sp3 hybridized carbon? Yes, it is a sp3 hybridized carbon. So halogen atom is bonded to a sp3 hybridized carbon, which is next to a aromatic ring, right? So this is attached to what? This is attached to a aromatic ring. So this is an example of benzylic halides. One more example I can give. This is also an example of benzylic halides. Just check R dash H, right? So this is also example. So halogen atom is attached to the carbon, which is next to a, okay, carbon atom, which is sp3 hybridized, which is next to a aromatic ring. So this is also an example of benzylic halides. I feel it is clear. Okay, so next we'll go with the compounds containing sp2cx bond. So what is compounds containing sp2cx bond? So the first is vinylic halides. So what are now vinylic halides? Okay, so vinylic halides are those in which the halogen atoms, okay, vinylic halides. So these are the compounds in which the halogen atom is bonded to sp2. Okay, it is bonded to what? It is bonded to sp2 hybridized carbon atom of a CC double bond. Now, how I will give the example? Okay, just see. So the example CH2 double bond CHX. So what did I say? So halogen atom. Okay, here the halogen atom is bonded to the carbon, which is sp2 hybridized. Is this carbon a sp2 hybridized? Yes, because it is doubly bonded. So here the halogen atom is bonded to sp2 hybridized carbon, okay, of a CC double bond. So this is a carbon which is having a CC double bond. So these are called as vinylic halides. Okay. So remember what is allylic halides, what is vinylic halides. One more example. So this is a haloalkane. We'll give for haloarenes. So is this example clear for haloarene? Right? So halogen atom is attached to a carbon which is sp2 hybridized of a carbon-carbon double bond. Understood? So these are vinylic halides. Next is aryl halides. So what do you mean by aryl halides? So aryl halides, in this, the halogen atoms is bonded to a sp2 hybridized carbon of the aromatic ring. So just see, is it clear? Yes. So what did I say? Aromatic halide. So here you can see that the halogen atom is bonded to the carbon which is sp2 hybridized, right? So this is a carbon. So this is a carbon which is sp2 hybridized here, right? So this is a carbon which is sp2 hybridized of the aromatic ring. So these are the example of aryl halides. So these are the example of aryl halides. So alkyl halides is clear, allylic halide is clear, benzylic halides, vinylic halides, and aryl halides. So these are based on the hybridization of carbon atom. So allylic, benzylic, alkyl halides comes in sp3cx bond, and vinylic and aryl bonds comes in sp2cx bond. Okay, understood? Is it clear till here? Yes, is it clear? Okay, so first, before going, so these are the methods of preparation of haloalkanes. So before going for methods of preparation, we can just solve some questions based on the classification and the introductory part. Okay, so the first question goes like this. Monohalo, dihalo, trihalo, and tetrahalo are types of haloalkanes and haloarenes based on the A, type of halogen atom, B, number of halogen atom, C, nature of carbon atom, D, hybridization of carbon atom to which halogen is bonded. Yes. What is the answer? Monohalo, dihalo, trihalo, and tetrahalo are types of haloalkanes and haloarenes based on. Please read the question properly. Don't be in hurry. Yes. Yes, Hemant's answer is right. What about others? Okay, Pragati has also answered it right. No, Vinushri, your answer is not right. Where did we see this? Here, monohaloalkane. So it depends on what? On the basis of number of number of what? Halogen atom. Okay, so option B. Right, option B. Yes. Suhas, Muskan, yes, answer is right. So it is B. Okay, so it is based on the number of halogen atom. Why? You have seen. So monohalo, dihalo, trihalo means what? Mono means one halogen atom. Di means two halogen atom. Three. So the tetra means four. Means what? So these are the types of haloalkanes and haloarenes. So these are based on what? They are asking like that. So it is based on what? It is based on the number of halogen atom. So it is based on the number of halogen atom. Understood? The question is clear now. Next, a monohaloarene is an example of A, aliphatic halogen compound, B, aromatic halogen compound, C, alkyl halide, D, side chain substituted aryl halide. Please read the question twice, okay, and see the options and then you answer. Simply don't make hurry. Yes. Muskan has answered it as B. What about others? Hemant has answered it as B. Suhas is answering at C. Sanvi is answering as B. What about others? Okay. Shall I tell the answer? So the answer is B. Okay, the answer is B. So it is a aromatic halogen compound, monohaloarene. Monohaloarene. So I'll write the structure. Monohaloarene means one halogen atom. So this is an example of what? Aromatic halogen compound. Okay, aromatic halogen compound. So this is an example of aromatic halogen compound. So we'll go for the next one. So whoever has answered it as B, the answer B is correct. So we'll see the next one. So others, please try. Okay. So what is the general formula for haloalkanes? X is the halogen atom, N is 1, 2, 3, etc. So these are the options as below. A, CnH2nX, B, CnH2n plus 1x, C, CnH2n minus 1x, D, CnH2n minus 3x. Yes. Okay, Spruti has answered it first. She's telling it as B. Pragati has answered it as B. Hemant is also answering as B. Sita, Vinushri, Suhas. Okay, so B is the right answer. It is CnH2n plus 1X. Okay, so this is the general formula for haloalkanes. Okay. Next question. Which of the following compounds contains an allylic carbon? So these are the four options. Please go through the options and tell me. Allylic, vinylic, don't get confused. Okay, what is allylic? What is vinylic? So you have to tell among the following which is the example of compound which is containing a allylic carbon. Okay. Who has answered it as B, Pragati A, Sneha D, Kirti has told it as A. Okay. So again, Sita has told us A. So the answer here is A. Okay. Answer A is the right answer. So you can see here in A. Okay. So what is allylic carbon? The halogen atom is attached to the carbon, which is sp3 hybridized, which is next to a carbon containing double bond. So this is a allylic carbon. Okay. So A is the answer. Yes, good. So most of you have answered it as A. So A is the right answer. Good. Okay, so we'll go for the next now. Which of the following categories does the compound belong to? A, primary haloalkane, B, secondary haloalkane, C, tertiary haloalkane, D, haloarine. Yes? Okay. The answers I got it as, okay, so most of you have answered it as A, and A is the right answer. Okay, so the answer A is the right answer. So it is a primary haloalkane. So it is a primary haloalkane. Okay, so that is halogen is attached where it is attached to a haloalkane. Here haloalkane is a cycloalkane here, right? So R, this is your RX. So it is a primary haloalkane. Good. So we'll go for the next one. What is the nature of the circled C, that is carbon atom, in the following compound? So this is, you have to tell what is the nature of this particular carbon. Okay. So A, is it sp2 hybridized, B, allylic carbon, C, benzylic, or D, vinylic? Okay. So Pragati has answered it as C, Sneha C, Suhas B, Sita is telling it as C. They have asked what is the nature. They have not asked what type of compound it is. What is the nature of this carbon? What is the nature of the carbon? It is carbon is attached to what? This is attached to a carbon which is sp2 hybridized. So the nature of the circle, it is a sp2 hybridized. Okay. So option A is the right answer. So option A is the right answer. So it is option A. So option A is the right answer. So we'll go for the next one. In which of the following cases will compound be a tertiary halogen compound? So when the compound will be tertiary, so these are the following options. Just see R dash, R double dash is H, R dash will be CH3, R double dash will be H, C R dash H, R double dash CH3, and D R dash is equals to R double dash is equals to CH3. So in which case, if you take R dash and R double dash, which atoms, okay, based on that, when it will be a tertiary halogen compound, depending on what? Okay. Sita is answered as B. When do you say it is a tertiary carbon? See, I'll give you an example. This is a primary. Okay, this is primary. This is secondary. And this is, sorry, just a second. So this is primary. So this is primary. Okay. This is secondary. And this is tertiary. Okay. So in which case it will be a tertiary halogen compound? What you have to take? R dash, what it should be? H or CH3, one will be CH3, one will be H, this will be H, this will be CH3. How? See here. Now this is X, this is C. Okay. So one of the atom, this is R. This is a aryl group. So this is R. Okay. Then if R dash, so for tertiary halogen atom, R dash should be what? This should be alkyl group and this also should be a alkyl group. Then it will be a tertiary. If I take one H, if I take one as H, what will happen? It will become secondary. If I take both as H, it will become primary. Okay. If I take if I take this H and this CH3, still it will become secondary. So if you want to make it as tertiary, what you have to take? Both R dash and R double dash as CH3. So which is our answer? Option D. Understood? So this is the condition. So whenever you want to make tertiary, all the alkyl groups or aryl groups should be present. So option D is the right answer. I hope you have got it. So we'll go for the next one. Which of the following is a vinylic halide? Okay, now I'll write the structures of each. CH2, CH, CHCl. So this is the first structure. Then B, CH3, CH, Cl, CHCl and CH3. Then C, CH3, C, CH3, double bond CH, then CH2, Cl, then D is CH3, CH, double bond C, Cl, then CH2 and CH3. Yes. What is the answer? Pragati has answered it as D. What about others? What about others? Okay, Sanvi is telling it as D. Vinushree has answered it as A. So Muskan has also answered it as A. A is wrong because it is an example of allylic halide. Allylic halide, you can see that halogen atom is attached to a carbon which is next to a carbon having double bond. So this is a allylic halide. We have asked what vinylic halide. Vinylic halide means it will be sp2 hybridized. Okay. So halogen atom should be attached to the carbon which is having double bond. See now. Which is the right answer? Yes. Which is the right answer? It is D. Okay, it is D. How it is D? See here, halogen atom is attached to the carbon which is having double bond. So this is an example of vinylic halide. Allylic, you are saying allylic halide. Allylic halide is what? Allylic halide is halogen atom is attached to a carbon which is next to a carbon-carbon double bond. This is allylic halide. Okay, this is an example of allylic halide. What is vinylic halide? Halogen atom is attached to the carbon which is doubly bonded. So we want this, not this. Okay, just see this type of example where it is Cl is attached to the carbon which is doubly bonded. So D is the answer. Understood? Understood? Don't get confused between allylic halides and vinylic halides. Allylic halides is this. Halogen atom is attached to a sp3 hybridized carbon, okay, which is next to a carbon-carbon double bond. And in vinylic halide, what is happening? Halogen atom is attached to a carbon which is sp2 hybridized of the carbon-carbon double bond. Okay, so it is, so this is vinylic. So write down this. Okay, so it will be more clearer for you. So this is allylic and this is vinylic. Okay, vinylic halide. Understood? So we'll go for the next one. The compound C6H5F. Okay, the compound C6H5F is an example of. So C6H5F. So is it an example of allylic halide, benzylic halide, vinylic halide, or aryl halide? Pragati, okay. Pragati has answered it as D. Tejaswini, B. Sneha is telling B. Vinushree has answered it as D. Hemant, D. Megha, B. Muskan, D. So the answer is D. Okay, aryl halide. So this is an example of aryl halide. So this is a aryl group and this is a halide group. Okay, benzylic means what? Benzylic means this. CH2Br. So this is a benzyl. So this is a benzylic halide. Okay, so this is benzylic group. So when benzene with a CH2 is called as benzylic halide. So B is wrong. D is the answer. Okay, D is the answer. So it is aryl halide. So this is a aryl group. Aromatic ring is called as aryl group, and this is halogen. So this is the example of aryl halide. Next, the compound in which a CH2Br group is attached to a benzene ring is an example of aryl halide. Is it true or false? So if I say this is CH2Br, so is it aryl halide? So is it true or false? Okay, B. Papu has answered it as B. Tejaswini, B. Sneha, B. Muskan, B. Sanvi, B. Yes, and B is the answer. Okay, so it is false. It is false. So these are called as what? These are called as benzylic halides. Okay, these are called as benzylic. These are called as benzylic halides. Okay, aryl halides are what? Aryl halides are this. These are aryl halides. Any X, I can write in general as any X, any halogen atom attached is called as aryl halides. Okay. So it is a false statement. So we have completed the classification part. Now we will go for the methods of preparation. So please remember what are vinylic halides, what are allylic halides, what are aryl halides, what are benzylic halides. Okay, don't get confused. Very important they are. So now we'll see the methods of preparation. So we are going to see the methods of preparation of haloalkanes. Okay. So haloalkanes can be prepared basically from alcohols. Okay. So these are the 5 main reactions with alcohols to prepare the haloalkanes. So alcohols, firstly, first reaction is with phosphorus pentachloride. Okay. The first reaction is with phosphorus pentachloride. So alcohols, when they have reacted with phosphorus pentachloride, they give chloroalkanes. What are obtained? Chloroalkanes are obtained with POCl3 plus HCl as the side products. They are the byproducts. Okay. So so by this you can obtain your chloroalkanes with PCl5, that is phosphorus pentachloride. So this is a first reaction. So when alcohols are treated with phosphorus pentachloride, you yield chloroalkanes. Okay. Then the next is alcohols. Okay, alcohols when they are treated with thionyl chloride. So alcohols when they are treated with thionyl chloride in the presence of a base called as pyridine. So pyridine is the base. So it will abstract. Okay, it will abstract the proton. Okay, it will abstract the proton. And it will yield what? Chloroalkanes again. So again here what are obtained is chloroalkanes. So chloroalkanes are obtained when you reflux or heating. Okay, you heat your alcohols with thionyl chloride. SOCl2 is called as thionyl chloride. So if you continuously heat alcohols and thionyl chloride in the presence of pyridine, you yield chloroalkanes. Here the chloroalkanes which are obtained, they are the yield is more because the byproducts which are obtained. So basically to prepare chloroalkanes, this is the suitable what you say method of preparation. Why? Because the byproducts which is obtained is SO2, that is sulfur dioxide, and HCl. Okay, so it is sulfur dioxide and HCl. So these are the byproducts which are obtained. So these are what? These are gases. So it can be easily escaped out. Okay, so gases can easily escape out. So we can yield the product in a good quantity. Okay, so most probably for preparation of chloroalkanes, we make use of this particular method. So what we are doing, that is alcohols are refluxed. Okay, they are heated in the presence of thionyl chloride. With thionyl chloride, they are heated or they are refluxed in the presence of a base called pyridine, and you obtain chloroalkanes. So the byproducts which are obtained are sulfur dioxide and hydrogen chloride. Okay, so this reaction is called as Darzon's reaction. So always in organic chemistry, the name reactions are very important. So remember the conditions in Darzon's reaction. So this is a Darzon's reaction. It is called as what? It is called as Darzon's reaction. Okay, so these are the two reactions which we have seen. Then the next reaction is with alcohols when they are treated with phosphorus trihalides. So phosphorus trihalides, when they are treated, you obtain your alkanes. Okay, you obtain alkanes, that is chloroalkanes. Okay, respective halide, alkyl halides are obtained, and orthophosphoric acid is obtained. So X can be your Cl, Br, or iodine. So this is the reaction. So here the reactivity of halogen acid towards the reaction with alcohols is HI is greater than HBr is greater than HCl. So depending upon the size of the atom. So as you know, in halogen atoms, that is group 17, as you go down the group. Okay. So how is the arrangement? Fluorine, chlorine, bromine, iodine. So as you go down the group, what will happen? There will be addition of new subshells. So as you go down the group, as there is addition of new subshell, what will happen to the size? The size will increase. Thus, iodine will have a greater reactivity towards the alcohol, then bromine, then chlorine, and then fluorine. So this is the reactivity of halogen acid towards the reaction with alcohols. Okay. So this is the reactivity. So remember, the reactivity is very important. The next reaction is with Ki plus orthophosphoric acid. So potassium iodide, when you treat alcohol with potassium iodide and orthophosphoric acid, you obtain iodoalkanes. Iodoalkanes are obtained plus water molecules. So this is the best reaction for preparation of iodoalkanes. Okay. Then the next reaction is with Lucas reagent. So remember, what is Lucas reagent? Lucas reagent is anhydrous ZnCl2. Please note it down. Very important. What is Lucas reagent? Anhydrous ZnCl2 plus concentrated HCl. Plus concentrated HCl is nothing but your Lucas reagent. So what is Lucas reagent? Anhydrous ZnCl2. There is no water contained. Anhydrous, there is no water. Okay, so anhydrous ZnCl2 plus concentrated HCl is called as Lucas reagent. So when you treat alcohols with Lucas reagent, you obtain chloroalkanes plus water. So another important name reaction is Groove's process. Okay, so what is the function of this ZnCl2? So it weakens the bond between the COH. Okay, that is alkyl OH bond. So this is COH bond. So ZnCl2, it plays a very important role in weakening this COH bond. Okay, so it breaks this COH bond to form a chloroalkenes. Okay, so this is another important. So remember, what is Darzan's reaction? What is Groove's process? So very important. So these are some of the methods of preparation of this what alkyl halides from alcohols. Okay. So these are the methods of preparation of alkyl halides from alcohols. So these are mostly the very important 5 reactions. Then the next is from alkenes. Okay, from alkenes. So suppose you have a symmetrical alkene. So whenever you have a symmetrical alkene, the addition across the double bond will takes place. Okay. Symmetrical means what? When you divide the, okay, between the bond, if you divide it, so there are same number of atoms on both the side across the double bond. So this is called as symmetrical alkenes. Now, whenever you want to add, suppose I want to add water across this double bond. So water will split into H plus and OH minus. So either of the side, any of the carbon, so CH2 double bond, CH2 plus H2O. So what will happen? So on any of the bond, okay, H, C, C, H, 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 H. So either H can attack this position and OH can attack this position, or OH can attach this carbon and H can attach this carbon. So it is symmetrical. Either of the carbon, it can get attached. But so whenever it is a symmetrical alkene, suppose there is an unsymmetrical alkene. What do you mean by unsymmetrical alkene? Unsymmetrical alkene means, now if I divide the bond, this double bond, across the double bond, if I divide, you can see the number of carbon atoms are similar on both the sides. No, here there are 2, here there is 1. So they are said to be an unsymmetrical alkene. Now, how does, whenever you have an unsymmetrical alkene, then how does the addition takes place? So that time we need to follow a rule called as Markovnikov's rule. So what does Markovnikov's rule state? So if I want to add HBr, that is a halogen acid. So if I want to add a halogen acid across this double bond, so it need to be followed a Markovnikov's rule. Now, what do you mean by Markovnikov's rule? So in Markovnikov's rule, so whenever you have an unsymmetrical alkene, the addition of halogen acid takes place in such a way that the negative part, so if I break this bond, this will break into H plus and Br minus. So the negative part of the halogen acid will be added to the carbon which is having least number of hydrogen atom, and the hydrogen will be, the positive part will be added to the carbon having more number of hydrogen atom. So how the this will takes place, addition. So the answer will be CH3, CH, Br, and CH3, right? So this is your Markovnikov's rule. So what does Markovnikov's rule state? Whenever you have an unsymmetrical alkene, so the negative part of the halogen acid will be added to the carbon having least number of hydrogen atoms, and the positive part of the halogen acid will be added to the carbon having more number of hydrogen hydrogens. Okay, to the carbon having more number of hydrogens. So this is Markovnikov's rule. So whenever you have unsymmetrical alkene and you want to add any halogen acid, you have to follow what? You have to follow the Markovnikov rule, wherein you have to add the negative part to the carbon with least number of hydrogen atoms, and you have to add the positive part to the carbon having more number of hydrogen atoms. Okay, so this is your Markovnikov's rule. Now there is something called as anti-Markovnikov's rule. Okay, what does anti-Markovnikov's rule tells? So in anti-Markovnikov rule, it is it will proceed in the presence of a peroxide. So suppose you have again, what you have? You have an unsymmetrical alkene. Suppose you have an unsymmetrical alkene. So if you want to add a hydrogen acid and there is some peroxide, okay, if there is some peroxide. So if there is some peroxide, what will happen? It will, the Markovnikov rule will be reversed. Means what? Here in the presence of peroxide, Markovnikov rule will not be followed. It will be followed as anti-Markovnikov rule. So whenever there is peroxide, what will happen? The negative part will be added to the carbon which is having more number of hydrogen atoms. So what will be the answer? It will be CH3, CH2, and CH2Br. So like this will be the answer. So whenever you have a anti-Markovnikov rule, that is in the presence of peroxide, negative part will be added to the carbon with more number of hydrogen atoms, and positive part will be added to the carbon with the least number of hydrogen atoms. So this is in the presence of peroxide. So whenever on the arrow, if peroxide is written or anti-Markovnikov rule is written, then it will be reversed. Okay. So in Markovnikov rule, both the products are formed. Okay. This product is also formed, and CH3, 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 this also is obtained, but this is a major product, okay, and this is a minor product. So the yield here will be more and here it will be less. So Markovnikov rule and anti-Markovnikov rule. So how does it goes? Understood? Okay. So so this is Markovnikov's and anti-Markovnikov rules. So some examples and other methods of preparation we can see in the next class. Okay, I hope whatever has been taught till now, it is clear. Yes, it is clear till now. Whatever has been taught, the classification, the MCQs based on that, and some of the methods of preparation. So next class will be solving. So first we'll see, we'll complete this methods of preparation. Okay, then we'll solve some MCQs, then followed by the other part. Okay, is it clear whatever has been taught till now? Yes, it is clear. Any doubts? Okay, so so I will end the session here. Okay, so we'll meet in the next class. Thank you.